This is Mrs. O'Neill for AP Chemistry, Chapter 3, Section 1, Stoichiometry. Make sure to understand the key terms on page 104. You pour vinegar into a glass of water containing baking soda and bubbles form. You strike a match and use the flame to light a candle. You heat sugar in a pan and it turns brown. The bubbles, flame, and color change are visual evidence that something is happening. To an experienced eye, these visual changes indicate a chemical change or chemical reaction. Some chemical changes are simple, others are complex. Some are dramatic, and some are very subtle. So if you notice, this is a picture of your vinegar and baking soda forming those bubbles. And really, vinegar is acetic acid. Get used to this. You're going to see acetic acid many times throughout the course. This is sodium bicarbonate. I like to say sodium hydrogen carbonate because it tells the formula better. So these are the three products that it forms: sodium acetate, water, and carbon dioxide. So which of these three things do you think is the bubbles? The carbon dioxide is what's causing those bubbles, just like in soda. So in this particular section called chemical equations, it's going to talk about balancing equations. Your objectives is going to use chemical formulas to write these equations that represent really chemical reactions. Again, I suggest you pause the video, write in the blanks, and then listen to hear my words. So a chemical equation is the same as a chemical reaction, and it just describes what's going on in that reaction. So we always want to remember it's reactants yields products. Reactants yields products. So reactants are to the left of the arrow, and the products are to the right of the arrow. love my little jokes. So a balanced equation, we want to make sure that there are the same number of each kind of atom on both sides. So we're going to use coefficients in front of our substances. I want to remind you that a substance can be the elements or a compound. So any element or compound is considered a substance. So we need to put coefficients in front of them in order to make sure that the whole equation is balanced. So if we look at this as an example, you should know now that this is methane from our organic chapter 24. We add it to oxygen. So if we have a hydrocarbon like methane and we add oxygen, this is a combustion reaction or a burning reaction. It's going to form products of carbon dioxide and water. Notice I put the list in the middle. So I list all of the elements that are in the reaction. I also remind you that hydrogen and oxygen you should keep last. So I always do all the elements first, hydrogen, and then keep oxygen at the very, very end. Then I list on both sides how many carbons on the left, how many carbons on the right, how many hydrogens on the left, how many hydrogens on the right, and so forth. Then I go to the top. All right, carbons are balanced, so I'm going to go to the next one. Hydrogens are not balanced. We have 4 on the left, and we need to get 4 on the right. We only have 2. So what number here, this would be the coefficient, what number here times 2 would give you the 4 that you need? Hopefully you said 2. So that's going to change the hydrogen from a 2 to a 4. And it's also going to change the oxygen from a 1 to a I'm sorry. It's going to change. We're going to have 2 of these, but we have to add the 2 that are here. Boy, is that tricky. So 3 to a 4. So glad we caught that. All right, so let me do that one more time. I'm going to back up, go backwards a little bit here. So again, we made our list. We're going to check that the carbons are balanced. We're going to look that the hydrogens are not balanced. So what number here to make 4 total? So 2 times 2 is 4. So that's what the hydrogen changes. And now the 2 also goes with the oxygen, but we're going to add it to the number of oxygens we already have here. So 2 plus the 2 gives us the 4 now. Okay, back to the top. Carbons are still balanced. Hydrogens are still balanced. Oxygens are not. So what number here do we need to multiply by 2 in order to get the 4 to equal the other side? You guessed it, a 2. That changes to a 4. So 1 carbon on each side, 4 hydrogens on each side, 4 oxygens on each side. We are now balanced. So those 2's that we put in front of the oxygen and the water are the coefficients. So these are just what you will see after most substances. So if you see a G, just means that's in the gas phase. L is liquid phase, S is solid phase, and AQ just means aqueous. That means it's some kind of solution. So simple things like sodium chloride solution. So you can have sodium chloride as a solid. That would be your normal salt that you sprinkle on your food to make it taste good. But if you put salt into water, now you've made a solution. You've made an aqueous solution, and that's where the AQ comes from. These indicators are going to be really important in Chapter 4, so make sure to keep an eye on those. That's it. See you in class.